Items, we have 7.5 day 2. This is our last section for chapter 7. We have 2 days of review and we have the chapter 7 test on Thursday. Now keep in mind you have 6 days more, so you go through the remainder of this week and next week on chapter 8, and then there'll be a review on Monday in the chapter 8. And then we'll have 2 days, 3 days on chapter 6, a review, and we'll test. And then it's review time, and we're done. Okay? I mean, it's going pretty darn quick. Yeah. Final will cover the entire year from day 1 to day 2 to our last day, because do day 2, as far as I'm concerned, that's how fast it goes when you're my age. Boom, 48 hours later, we're done. Just make sure the question that's out there is, well, what will the final cover? It'll go through chapter P, which is your prerequisite chapter, all the way through chapter 8. We will not include chapter 6 on it. Really. It's the whole deal, nothing but the deal. But keep in mind, this class is taught in a college setting in 18 weeks. And the final is supposed to reflect the entire course. Okay? Pardon? It is a semester. Semester is 18 weeks. You will have spent the equivalent of 36 weeks in the course. Okay, and we are much nicer because in the college course you would be given 2 tests, a semester, midterm, and a final. And that midterm would have covered the trig stuff. So that would have been the first part of the trig stuff. That first midterm would have happened and stuff. Pardon? It is. I have it equally weighted as the other tests. Yeah, currently 50. There are 50 questions. It's going to go straight out. You will take a calculator, no calculator test for chapter 7, and I am, be honest, except for maybe 7 questions, you should be able to do the entire final without a calculator. Okay, calculator free, and we are working towards that. If not this year, it's next year, but I would expect it that be this year. There is no need for a calculator on the final whatsoever. Just like the SAT or ACT, and I would not give you one if that was the case. Yes, sir. It does. It does. And actually, I have reviews that are available. I think I already got them online along with the solutions, but you guys will be able to bring them up. I'll give them to you the first 4 chapters prior to Labor Day or Memorial Day, and then we'll do the last 2, 7 and 8 afterwards. Yes, sir. They're pretty even. It's like 50. There's 8 chapters, so it's about 5 to 6 questions per. The units that we spent a lot more time on take a lot more questions up. Okay, so it's pretty nicely balanced, I thought. But keep in mind, chapter P and chapter 1 and 2 are algebra 2 chapters, so there's less stuff from there than there are from chapter 3, 4, 5, 6, 7, and 8. Okay, any other questions? Okay. The reviews, I will start handing those out. You'll actually get the chapter 1, 2, 2, 3, 4, 5 reviews will be out before Memorial Day. Okay, you'll get those like at the start of chapter 6. I'm just going to hand it to you one day in class. Reason being is if you can plan accordingly, because I know other people will be out there and getting things done, and if you have questions, you can ask about them and stuff. So just keep that in mind. That'll be coming out to you. Today we got 2 questions. 2 questions. I want to make sure you know how to do them. The expectations, if you come across them on the test itself, is that you can do it calculator free. You do have the opportunity to check your work with a calculator. We'll talk about the setups first. And I have this one kind of set up before we start. And really in these linear programming things, you have an X and Y you've got to answer. Okay, you're going to fill an X and Y. You got to minimize or maximize something. Most of the time in a linear programming problem, you won't see both answers, the max and the min. And this one you will, if I remember correctly on the example 7. For sure, example 6, we saw the min and the max, and we were supposed to minimize it, so that's what we did. But here, let's just start talking about it. Johnson's Produce is purchasing fertilizer with 2 nutrients, nitrogen and phosphorus. They need at least 180 units of nitrogen and 90 units of phosphorus. Their supplier has 2 brands of fertilizer for them to buy. Brand A costs $10 a bag and has 4 units of nitrogen and 1 unit of phosphorus. Brand B costs $5 a bag, has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. How many bags of each brand should be purchased to minimize this cost? Okay, as we go through. I mean, it is cost, it's about cost minimization. I mean, it's not about, oh, just buy it. Okay, so you want to make sure we're going through if you're going to be running a business. So I've got this, X is the number of bags of brand A, Y is the number of brands bag B, for number of bags of brand B as we go through. So let's reread this. And as we're looking through, they need at least 180 units of nitrogen and 90 units of phosphorus. So my 180 units of nitrogen I've got 4 bags of nitrogen for brand X and 1 for phosphorus. And then I got 1 nitrogen, 1 phosphorus. And then these are supposed to combine to be greater than 180 or greater than 90 parts, okay? Because they say in the problem, they need at least, and that's why, because of that at least, that's why it's greater than or less or equal to, at least, when I get away from that. Are you okay that I'm setting it up? I've got brand A, I got brand B going on. Remember, brand A costs us money, more money. Brand A was $10. And brand B is $5. So if I'm going to actually purchase those 2 bags, I've got this set up here. And they said that the produce can pay at most $800. So the most I could pay is $800 out. I've got a limiting factor. So I got a max of what I can spend, okay, for this, as I go through this. But I haven't quite gotten my formulas in yet. Okay, based on the information that I've got provided, okay, as I'm going through, I've got my 10x plus 4x has got to be less than or equal to 800. But I got 4x plus y is greater than 180, and x plus y is greater than 90. So I've got those formulas in here, pretty much just talking about the equations that I've got from my story. And I wanted to make sure I wrote it down and got out of your way so you guys could see that. But think about where I got them from. And every time I set up a linear programming problem, I got it X needs to be something, Y needs to be something, and then I set them up so I can quickly find my equations. Okay, there'll be two things I'm comparing as I go through this. Please notice that in the linear programming stuff, we're always working with quadrant 1. Okay, so I have my x is greater than or equal to 0 and y is greater than or equal to 0 is there because we're talking about quadrant 1. And if I'm going to be graphing that quadrant as I go through here, so I'm sitting here, I've got this part and this part going down as I do that because that's my x and is greater than or equal to 0, which is x is equal to 0, that's that vertical line, and y is equal to 0, it's a horizontal line. And now I've got to graph the other pieces. My equation as I go through, I've got y equals negative 4x plus 180. That's one graph I've got to do. And I've got to make a decision on what I'm going to do as far as going up by my units on my graph. And I went up by tens on this, okay, just to make my life easier. And here I've got this equation, y equals negative y, excuse me, not negative y, but negative x plus 90. And then my last one here, I've got y equals negative 2x, and what is that, 160? Yeah, plus 160 as I go out. Okay, so I've got those equations I got to graph. So if I'm going to put in my calculator, it'll look something like this. I can put those equations in my calculator and I can quickly find them. You know, if I wanted to actually see what it looked like in my calculator. But please be advised, on a test or a quiz, whatever it is, I expect you to show me those formulas, show me the stuff that you graph in the problems when we come across them. Okay, so when I'm graphing these, and if I go up by tens, okay, as I'm going, we can get that over there so I can get more space here. My first one, as I go through, if I graph any one of them, I'm just going to graph this one. This is probably, I'll just go as we go. I got negative 4x plus 180. Well, if I start out here at 180, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I start up here, I'm going to be coming across 180 here, and this is my graph coming up here as I go through with the 2. Apparently I killed my graphs. But if I get this going, I've got those graphs and I put them in as the original so you can see what's going on. But my picture looks like that as I come through with my 3 graphs. Go ahead and get your graphs. I went up by tens on each thing. Maybe perhaps I will show you that that's what I've got. This is 50. This is 100. This is 150. 50. 100. 150 as I go up. Now, one of the interesting things about this system that we're doing, that everything's greater than 4x. So if I put in 0, 0 on any of these, 0 is greater than 180, 0 is greater than 90, 0 is less than 160. Well, that kind of works. That 0 is less than that 160, which is that 800 one. That's this one. So that's in there. But the other two are this way. The other two go this way on both graphs. So I'm looking for this point, I'm looking for this point, and I'm looking for this point as I go through and I set up my graphs. Are you okay with where I'm going? Yeah. Mm-hmm. Well, I went up by tens, right? So I go 180, but I just plug in points. So if I've got this coming through here, I could go 16 here, or 160 actually, and 0. That's going to give me my 180, my 800, I should say, not 180. But that'll come up with my, and actually it's not, it wasn't 8, it was 16. I'm sorry, I counted it funky. Because it's 0, 1, it's 0, 1, 6, 160 is my first one. I misspoke on that when I said up to 800. Yes or no? Okay, because this, I'm just graphing these 3. That's all I'm doing on it. Okay, so I've got, for this one, I've got 16 and 0, and another point that'll work out on it because it's 5 and 10 will be really great to be 2 and 14 or 4 and 13 as I go through, or 40 and 13 and 130. Any questions about that? I'm just graphing those 3 equations, and once I get them graphed, I'm going to shade them. Okay, so my points that I have here, I can pull that out there. I got 30 and 60 here. I got 10, 20, 30, 10, 20, 30, 40, 50, 60. And up here, I think I put it on the inside here. I've got 10 and 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. So I got 10 and 140. Now I pop that in, I should be able to come up with 100 and 700. So that's going to be 180 there. And then my last one down here I got 70, which is 10, 20, 30, 40, 50, 60, 70, and 20. The points where I'm crossing. No, ask the question if you've got it, Ms. Bever. What do you have? These are the points of intersection of my two lines, just like I did on Friday. So what we're doing, we have the 3 lines graphed. Are you okay with graphing those? Yes or no? Okay. The points of intersection of the graphs are the thing I'm here for. Now, whether it was just this one here or this one, if this wasn't included here, if it was everything was greater than, it would be on the outside. But because I have I'm going to put it in a different color. I have corners of overlap that are inside this triangle. So now I have these 3 points that I'm checking. That 10, 140, the 70, 20, and the 30, 60. All I'm doing is a system of equations with 3 equations. And I shaded them. Yes or no? And I showed you that I can do them with this in the calculator. I can even just graph those. But I expect you to be able to have it graphed and be able to find the points of intersection. Now, these points are pretty nice. I'll be honest. Okay? They came across really nice on the graph as I went through on the graphing. And I just did it by using slope, and I found those intersections. Any other follow-ups? And I just want to make sure it should, if right now there is some sort of like miracle step, it shouldn't be, because I've just used the basic stuff of graphing each line and shading, and it's the overlap of the shading. And it's that blue triangle that we're overlapping for the shading. Are you okay? Are you up to speed on it? Okay. Now remember, those are the corners. And those corners allow me to work with those other ideas. Now we've got this stuff on the side, so I'm just going to get rid of that. Okay, so the corners that we just found, 10, 140, 30, 60, and 70, 20, are the ones I'm going to use in our cost. And we have a cost as we go through here. Our cost is equal to 10x plus 5x. Okay, now we have a limit to the amount that we can spend, which is $800. Okay, and we're going to find out what combination is the cheapest on this. And the corners of our graph, this is the programming part, will let us know that. So all I'm going to do is I'm going to 10 times 10, 5 times 140. Let me add those together. That comes out to exactly 800. Okay. 30 times 10. I'll just go 10 times 30 for this next one. I've got 10 times 30 and 5 times 60. Okay, that's 300 there, and that's another 300. This is actually 600. And my next one is 10 times 70 plus 5 times 20, and that's an 800 as well. So right now I found out that I have a minimum of 600 cost, okay? So that minimum is what I'm going to be looking at. And keep in mind what that represents, that 30 and 60, okay? 30 is the number of bags of brand A, 60 is the number of bags of brand B as we go through this problem. So to minimize our costs, because the most they could spend is 800, okay? But they want to spend the least amount to get the same information or same material out of it. So when we finish the problem, we're looking at the idea that we on minimum cost is $600. We got to purchase 30 bags of brand A and 60 bags of brand B, not 6, but 60 bags of brand B to make this work. Now remember, got to find our relationships and how they work. We got to find equations to represent the story that's in the problem. when we're working with a linear program, we're going to have the limit of the XY axis will be in quadrant 1, okay? Our maximum and minimum are found on the corners, and that's based on our shading the system, and from that shading we are able to find our maximum and minimum, whatever we're looking for that problem. Any other clarifications for 7? Okay, 8's done in a similar manner, okay, as we're going. So let's check that one out, see what's going to happen. Okay, Gonza Manufacturing has 2 factories that produce 3 grades of paper, low, medium, and high. It needs to supply 24 tons of low grade, 6 tons of medium, and 30 tons of high grade paper. Now those are the minimums. If we end up setting up a system where we could produce more, then so be it, okay? Factory A produces 8 tons of low grade, 1 ton of medium grade, and 2 tons of high grade paper, and costs $2,000 per day to operate. So this is $2,000 a day to operate. And I like setting them up this way as we go, and maybe I should be honest about what I've got going. Let X be the number of days factory A is open, and let Y be the number of days factory B is open. Okay, so that's the first thing as we set this up. So I got a low, a medium, and a high grade paper each factory makes. Factory A produces 8 tons of low, so we got 8 tons of low, and 1 ton of medium, and 2 tons of high. Okay, and it costs $2,000 to operate that factory in 1 day. Factory B produces 2 tons of low grade paper, factory B, low grade, 1 ton of medium grade paper, and 8 tons of high grade paper. But factory B costs $4,000 a day to operate. How many days should each factory be open to operate to fill the orders at a minimum cost? Okay, so we're still looking at this idea of minimum cost. Okay. So, and also remember, as we went through, the low, it needs to supply 24 tons of low grade paper. So whatever it is, it's got to be greater than 24 tons. And this is in tons. Okay. 8 tons of medium grade, 6 tons of medium grade paper, and 30 tons of high grade paper. Okay. Now remember, those are minimums, and it's okay for my solution to have more of one of them produced. Okay. If it's great that all of them are produced perfectly and that we cover it, fantastic. But those are the basics of the setup. Are you okay that first of all I had the setup that X is the number of days factory A is open, Y is the number of days factory B is open. These are the things that factory A produces. These are the things factory B produces. The cost of the 2 factories being open is our objective function as we go through here. Now, we're supposed to minimize. We didn't get a limit to how much the factories, or like the most we'll expend for the factories being open on this problem. Okay, so we're looking for minimizing our cost setup. Okay, so when I get this going, you got to keep in mind what formulas I have. I've got 8x plus 2y is greater than or equal to 24. Okay, I've got x plus y is greater or equal to 6. And I've got 2x plus 8y is greater or equal to 30. Now, I've got a maximization thing, my cost differential, because we're going to have corners on this, and we're going to have an objective function. My objective function here is 2,000x plus 4,000y is going to equal my costs. And I want to minimize my cost. Are we doing okay with how I'm coming up with all the formulas? Okay, now as I go through, I can actually get these graphed. The things that I'll put on my graph for this one, I've got 2y is greater than or equal to negative 8x plus 24. So I got y is greater than or equal to negative 4x plus 12. So that's one of my formulas I'm going to put up. Another one, this one will go quick. I've got, and I should say my fences. And they're all solids, solid lines as I go. So this is one. The other one, I've got y equals negative x plus 6. And my last one, I've got 8y equal negative 2x plus 30 as I go through. And y is equal to negative 1/4, or x over 4 plus 30/8, 30 divided by 8. There. So I'm looking for points on my graph this is going to cross. Okay. X and Y are days this is open, that each factory is open, and we're producing paper on this. Bless you. Go ahead and graph those three functions, or the three linear fences, and go ahead and shade them. Find out what's going on to make sure we follow along with this. Each one we do is the same pattern. We've got to set up original information to break it down so we can get our linear functions. After we get them, we got to graph our fences and shade. And after we do that, we find our corners and we look for the maximum or minimum depending on the storyline that we're given. In this one, we're asked to minimize the cost. So we're looking for a minimum as we go around. Do you have notes? Yeah, okay. Let's go ahead and get those graphed as you go through. Get those linear things graphed in there. You can do it on your graphing calculator, but if you got your stuff set up, it goes pretty quick as we look through the function there. Maybe we can color code those and make it easier for y'all. This is my red function. And then I've got my black function, and I got my green function is the other one that goes out to 15. Should be about the same. So those are the setups that we're working with. And all of these are greater than. So if I put 0, 0, it's going to be an opposite 0, 0 in every one of the functions for a test function. It's always opposite the 0, 0 as I go. So although I do have the green's going to go up here, the red's going to go out here, and my black goes up here. Okay, and because of that, I have, let's see if I can come up with a color that I didn't use, blue. I have to find my corners here, 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 and here, where the overlap happens with all my shading. Are you okay with that for my corners? So once I get going on that, or not, our values that we have should be 0, 12, 15, 0, 3, 3. They come out pretty nice if I remember right. And 2, 1, 2, 3, 4, and 2, 4. As I plop those down on this side. Questions on how I found the intersections as we're looking them over? Any at all? Are you okay with the intersections and it's on the side of the overlap of all three inequalities? Okay, now because I've got those, I've got 0, 12, I've got 2, 4, and I'm just going to work my way down along them. I got 3, 3, and I got 15, 0. Now I'm just going to evaluate as I go. I've got 2,000, bless you, plus 4,000 times 12. Let's see if we can get some more space here. And this will equal 48,000. Okay. Then I have another one which is 2,000 open for 2 days and 4,000 that's open for 4 days. Okay, so I got 16 and 4, I got 20,000. Another 2,000, 3, and 4,000, 3. So that's 12 and 6, that's 18,000. My last one here, I got 2,015 times 15 plus 4,000 times 0. It's me 30,000. So the minimum number of days that I can have them open, so I can minimize my cost of $18,000. Okay, it's 3 days for Plan A and 3 days for Plan B. Okay, does that make sense as I step through it? We okay with the corners? Okay with why I'm able to come up with this objective function? And then the final thing as I go through it, a minimum 18,000 production costs to have each factory open for 3 days apiece. Okay, and now because of that, factory A makes 8 tons of low-grade paper and B is 2 tons. So I fit that 30 ton requirement. Actually, I think it was 24 tons. So okay, for my low grade. So I made more low-grade paper to make this work. My medium paper was supposed to be 6 tons. We make exactly 6 tons of medium grade paper. In my high grade paper, we were supposed to make 30 tons, and we make exactly 30 tons of high grade paper. So that is acceptable for the amount of time that my factories are open. So yeah, my lower grade paper, I made more, but that's the cheapest I can run everything and still fit all the required production quotas I'm supposed to have. Any other follow-ups with that? Now, please keep in mind, you will have a problem like this on the test. You will be in need of showing your linear picture, graphing your lines, shading them, showing your area that they have. And on this one, it's everything beyond here. It's this stuff right up here, because that's where the overlap happens for all 3 situations. And then you're able to take your corners with your objective function and show your maximum or minimum, whatever it is, and then explain yourself in your answer. Okay? Each one has the same pattern as far as what you got to do in each step. Okay. Are there any other follow-ups? Questions? Remember, it's about graphing and just being able to describe the graph. So make sure you're getting that time done. The assignments are coming through here are 7.5 day 1, and we have 7.5 day 2. So day 1 was done on Friday. Day 2 is today. It's also up on the board. It's also up on Schoology. Okay. So if you have questions, please ask. Okay.